let's compare light to sound. Remember, we can use interchangeably the word light to electromagnetic wave. Anyway, light is an electromagnetic wave, which means it can travel both with or without a medium. It can travel in vacuum and within matter as well. Sound is a mechanical wave. It cannot move without a medium. It needs matter to exist. Without matter, sound would not be produced. Sound cannot travel in vacuum since it's a mechanical wave. Now, all electromagnetic waves, whether it is the light we see, the visible light, or all other frequencies, they are transverse waves, meaning the vibration direction is perpendicular to the direction the wave travels, meaning that the wave is going to have the wave shape. Sound, however, is a longitudinal wave. The vibration direction is in the same direction as the direction the wave travels. The wave looks like a series of compressions and expansions. Now, for all types of waves, whether it is light or sound or any other wave, the speed of the wave depends on the medium. Moreover, when in the same medium, all wave frequencies travel at the same speed. Meaning, for example, radio waves like infrared, like blue light, visible light, or green light, visible light again, or ultraviolet or gamma rays, when they are in the same medium, all travel with the same speed. The same applies to sound, the sound we hear and even the sound we don't hear. For example, infrasound, the sound we don't hear that has frequencies below the frequencies of the sound we hear, and ultrasound, the sound also that we don't hear that has frequencies higher than the sound we hear, and the sound we hear, all of them will travel with the same speed when they are in the same medium. Now, for light, speed and the density of the medium have an inverse relationship. Light is fastest when traveling through vacuum, and then the denser the medium, the slower it gets. However, for sound, we have the opposite relationship. The speed and density of the medium for sound have a direct relationship. Sound does not move at all in vacuum. It is the slowest when it is moving through air. The denser the medium, the faster it gets. So we have opposite relationship. Be careful though, this does not mean that sound is ever faster than light. Here what we are doing is comparing sound to sound, sound in one medium to sound in another medium. And here we are comparing light to light, light in one medium to light in another medium. However, light is actually much faster than sound all the time. It does not matter what medium it is. Look at the speeds of sound. We are talking about 300 million here, which is about 1 billion feet per second. While sound is only 340 meters per second, about 1,000 feet per second. So basically, it is telling us that light is about 1 million times faster than sound. So there is no way to compare them. Light is always faster than sound. Now, the other property for all waves is that we can use frequency or wavelengths as identifiers of the wave. If we know the frequency, we are going to know what kind of sound wave it is or what kind of light wave it is. Similarly, if we know the wavelength, we are going to know what sound wave we have. In particular, for visible light, frequency and wavelength indicate the color of the light. For the sounds we hear, frequency and wavelength indicate the pitch of the sound. Now, amplitude for the light, it affects the brightness of the light. For sound, amplitude affects the loudness. The louder sound has a larger amplitude. The brighter light has a larger amplitude. When we have the same frequency waves, higher amplitude waves carry more energy. For the same frequency, when we have the same light wave, for example, for blue light with a higher amplitude would carry more energy than blue light with a lower amplitude. And we can say the same thing about sound.